All right, so we want to do some more integration by parts, and we want to tie this thing off, be done with it. And so that would mean that tomorrow we would investigate partial fractions, and then look to test on these topics that we've had. And I'll get you guys a study guide tomorrow then. And so we do your test Tuesday next week or Wednesday next week. I'll have to make a decision on that. Um, so we have the integral of fg is equal to what? Big F, little g. Is everybody okay with that? Is that all review? So I'm just trying to prime your brains right now and trying to get you back to understand what we did. Okay, prime. So so that's our formula for integration by parts. And what we did is we set up the product rule the other day, and we then tried to undo the product rule through integration, and that's what we came up with. And it was pretty cool. You guys liked it. Uh, so over the side here, I'm just going to do a sample problem again to remind everybody that if we have, say, the integral, so you can just kind of draw a space over here, integral of x squared cosine of x dx. So the other day we talked about our kind of our shortcut is that when we see something that kind of rotates over and over and over and over again, and we see something else that will eventually terminate by taking our derivatives, that we could just set up our little chart, right? Everybody remember that? So do you remember what we called f and what we called g? G is x squared because it eventually goes away. And then f is going to be cosine. Very good. I probably have an x in there. It's always good to have a variable. Um, okay, so I set up this little chart. And I go plus minus. I have G, and I like to put big F there. That helps me organize my work better straight across. So I know G is x squared, and then I take the derivative, and I get 2x and 2. What's the antiderivative cosine of x? Sine of x. So I put that here. What's the antiderivative sine? And what's the antiderivative negative cosine? And I go plus minus plus. And that will tell me my terms. Yep, it always is. So you can see my first term is positive. I have x squared sine of x. And then it looks like we're going to have another plus 2x cosine of x. And I'm going to have a minus 2 sine of x plus c. So that was a nice quick way of going through integration by parts, right? You all good? Okay, yes. I wouldn't use it for the whole thing. I mean, if you can make the shortcut method work for the whole thing, then that's fine. But yeah, without a doubt, like when we do, like when we set up this one right here, I don't set up the table. What I like to do is I like to look at examples like this one and this one. To me, these are two right away that I say obvious ones where we're going to set up the table and roll. So, yep, yep. Logan, what's up, buddy? Extra study guide. Okay, when I look at this example, what I like about it is that negative x cubed will eventually go away. And when I see sine of 4x, I know that that antiderivative will just continue to cycle around and around and around. Everybody agreed? Perfect situation to set up a table. What's more challenging about this is the antiderivative sine of 4x. That's one that people kind of get confused with. So let's start with the easy part. What's g? Negative x cubed. So the derivative, and then negative 6x and negative 6. So everybody good there? So I always use g to see how many terms I'm going to need till it terminates. Plus minus, plus minus. Now I need f. Huh. Katie's got negative 1/4 cosine of 4x. How in the heck did she come up with that? Chain rule. U is equal to 4x, so du is equal to 4dx. Divide by 4, you get 1/4. We all clear? I kind of showed you that just a little bit the other day, didn't I? So we have negative 1/4 cosine of 4x. Yes. Integral of sine of 4x dx. U is equal to 4x, so du is equal to 4dx. Divide by 4, 1/4 du is equal to dx. So therefore, you have 1/4 integral of sine of u du. Antiderivative sine is negative cosine, so negative 1/4 cosine of 4x plus c. Can you see that you're going to accumulate a 1/4 out front every time you take the antiderivative? So what's going to be the antiderivative of negative 1/4 cosine of 4x? Question, sir. Yeah, I mean, if it was 2/3 on the inside, then it would be 3/2. So yeah, then the antiderivative cosine is sine. So we have negative 1/16 sine of 4x. Then what? 1/64 cosine of 4x. 1/256 sine of 4x. So we're taking the antiderivative of this. So see how we got the 1/4? Go back to it. You're not dumb. So du is equal to 4 dx. We don't have a 4 dx, so therefore I divide by 4. 1/4 du is equal to dx. So you can see that we have that 1/4 multiplier out front, right? So I have 1/4 times the integral of sine of u du. And the antiderivative of sine is cosine. So what's going to, yep, negative. So what's going to happen is that every time we take the antiderivative of something with a 4x on the inside like this, we're going to accumulate another 1/4 and another 1/4. So you can see I have a 1/4 here. Well, this is a 4th times a 4th. This is a 4th times a 4th times a 4th, 4th times a 4th times a 4th times a 4th. So we collect all these 1/4ths out front. And that's the pattern that continues to develop. Well, 1024. 1024. So can I erase it? Okay. So now we multiply all these pieces together. Am I going to end up with a positive or a negative for the first one? Positive. And I end up with x cubed over 4 times the cosine of 4x. Next one, positive or negative? It is negative because I have 3 negatives. And I get 3x squared over 16 sine of 4x. Positive or negative? Negative. It looks like 3x over 32 cosine of 4x. And then positive. It looks like I'm going to get, let's see, 6 over 256 is going to reduce to 3 over 128. 3 over 128 sine of 4x plus a constant. Sure. Simplify what? Yes. 2/4 is 1/2. 6/10 is 3/5. And 2/17 is 2/17. So you can see that the table saves us a lot of work. It also helps us do more complex problems. So how long? Depends on who you are. Would you like me to say that in your case or Chris's case? I'm trying to give you an honest answer. You're pushing me here. For the average student, well, most students don't know how to do calculus, so. For the average calculus student, I'm going to say 10 minutes. Plus, minus. I have G and I have F. What is G? Derivative? 5x to the fourth, 20x cubed, 60x squared. Very good. I never doubted you. Apparently he did. Plus, minus, plus, minus, plus, minus. Is everybody clear about the initial setup? Is there any question on the initial setup? Now let's go to the more challenging piece. Let's find the antiderivative. I will set up the substitution so that everybody can see it. Integral of e to the negative 2x dx. I'm going to pause for a second. Anybody out there without doing the substitution, can you see right away what the antiderivative is? Negative 1/2 e to the negative 2x. So, if u is equal to negative 2x, then du is equal to negative 2 du. Do we have a negative 2 du? We do not. So negative 1 over 2 du, if I divide both sides by negative 2, is equal to, whoop, should be an x over there, dx. So it becomes negative 1/2 integral of e to the u du. What's the antiderivative of e to the u? E to the u, isn't that amazing? So you get negative 1/2 e to the negative 2x plus a constant. That's the antiderivative of e to the negative 2x. So every time we take the antiderivative of e to the negative 2x, what are you going to accumulate out front? A negative 1/2. Are you convinced by that? Okay, so we can just continue to add that negative 1/2 out front every time. So we learned that this one gives me a negative 1 over 2 e to the negative 2x. So what's the next one going to be? 1/4 e to the negative 2x. Negative 1/8 e to the negative 2x. That's kind of cool, huh? What do they all share in common? An e to the negative 2x. So how about we just write it in factored form right away? That way we don't have to write e to the negative 2x that many times. Let's see, 1, 2, 3, 4, 5, 6. We just have to write it once then. Is that okay? All right. Thank you for your judgment. E to the negative 2x times all of these quantities. First term, positive or negative? Negative. So I get negative x to the 5th over 2. Next term, positive or negative? Negative 5x to the 4th over 4. Did you notice that all the terms here end up being negative? Isn't that silly? Next term, I've got 20x over 8. I'm going to divide a 4 out, and I get 5 over 2. Is that right? 5x cubed over 2. 60 over 16. Divide that by 4, and I think I get 15 over 4. The next one, divide by 4. get 30 over 8. So 15 over 2. And the next one, I guess this is going to be 15 over 4 then. That's pretty cool, isn't it? Oh, he wants the big box. You want the big box? Yeah. You know, you look at it at the beginning and it looks pretty harmless, doesn't it? I mean, it starts out like that. Just the antiderivative of that little guy. Turns out that if you take the derivative of this using the product rule, it does simplify to exactly that. Who would have thought? Yeah. Oh, is it really? Riley, would you like to comment? Thank you. Sorry, YouTube Nation, made a mistake again. Very common. When he comes in, everybody clap. Everybody just stand up and just start clapping for him right now. Just. Okay. Oh, there he goes. Oh, he's scared of me. That's why he doesn't come into my class anymore. Yeah, he did. He's a jerk. All right, here we go. Negative arc sine of 5x dx. Same thing, right? Do you know the antiderivative of arc sine? That's the derivative. You don't know the antiderivative. Kelly just gave a very honest look. Hold on, wait, hold on. Do what's out there now. I'm done. Okay. Okay. All right, here we go. Do you know the antiderivative of arc sine? No, you don't. You only know the derivative. So therefore, this must be g. And when you first see the problem, you may say to yourself, well, what indication is there to us that we would even use integration by parts? Well, there's really not, other than the fact that you say, well, I don't know how to find this antiderivative on its own. So maybe integration by parts would assist me in some way. And so we're going to say that f is what? 1. And it looks like it's negative, so I guess you could call f negative 1 if you want. So therefore, we have big F, which is negative x times g, sine inverse of 5x. No, and you could try to go to set up the chart here. I really don't know if it really, I think it's going to, I think it's better teaching it, at the very least, for me to set it up this way. But minus the, thank you for agreeing with me. Thank you. So we got minus the integral of, now what I need is but I still have big F, right? And big F is negative x. So that's going to switch this to plus, and I have an x there, times whatever the derivative of arc sine of 5x is. You guys have great ideas. You're both incorrect. I'm sorry. Let's try this. So what we have is sine inverse of 5x, and we want to take that derivative. If you didn't notice, I need to use the chain rule. Because we have arc sine for the outside. What is the inside? 5x. What's the derivative of arc sine? Very good. And derivative of 5x, 5. So I get 5 over the square root of 1 minus 25x squared. You got to plug the 5x in for the u. 25x squared. So 5 over root of 1 minus 25x squared dx. What do you think? Are you okay with that? No? We got to find that antiderivative. So now you got negative x sine inverse of 5x plus the integral of 5x over the square root of 1 minus 25x squared dx. So now we just have to answer the question, what is the integral of 5x over the square root of 1 minus 25x squared? Substitution, what is u? 1 minus 25x squared. So here's where you don't have clear direction, do you? You got to be able to pull from different resources and things that you see. So as you look at this guy right here, if u is equal to 1 minus 25x squared, what's the derivative of 1 minus 25x squared? Negative 50x. And that's kind of like 5x, isn't it? I mean, it's just 1/10 away from it. So we're going to be all right. So let's do that. U is equal to 1 minus 25x squared. So du is equal to negative 50x dx. I do not have a negative 50x. I have a 5x. Negative 1/10 du is equal to 5x dx. So I take the negative 1/10 integral du, and what is gone? 5x is gone, dx is gone, and I'm left with 1 over the square root of u. Does everybody see that? Or u to the negative 1/2. What is the antiderivative of u to the negative 1/2? U to the 1/2 divided by a half, right? 2 roots of u multiplied by the negative 1/10, negative 1/5 root of u plus c. And so we have our entire piece. Negative x, arc sine of 5x minus 1/5 times the square root of 1 minus 25x squared plus a constant. Turns out that that is the antiderivative of negative arc sine of 5x. Pretty cool. I don't think we're ready for the last one. We'll just stop there. You guys can do your homework. So you can finish off your worksheet that I gave you the other day on integration by parts. Sure, you got it Friday, I think. No, we just kind of took it easy the past couple days.